Welcome to Scale Models. I'm Jason, your host, and I do models. And apparently electronics? What's up with that? Let's check out today's episode of Make Electronics, based on the book by Charles Platt. I think I called him Chris the other day. I'm sorry about that. And we did 12, some soldering, and now it is Experiment 13, roasting an LED. Let's see if I can tame that down a little bit. No, that didn't help. Alright, so let's go over what we have here. We need a 9-volt battery and a connector, or a 9-volt power. I have 9 volts on my power supply. My test equipment is this singlet test equipment. See, the power supply is the SPD3303XE. That is what I'll be using. I may be using the on-screen software. We'll see how this goes. Let us take that off. I will get the software opened just so I have it for when I need it. Let's go to open that. Okay, so there is the meter software. We can go ahead and take the meter software off, and we will have the power software when needed. So there we go. It's not at 9 volts yet, but we'll set it when we get there. Okay, so I have some long nose pliers right here. So I have the long nose pliers. We have a soldering iron. We have the TS80P. We need 2 generic LEDs. We'll grab some red ones because they're right here. So we got some LEDs. Some 470 ohm resistors. We just need one 470 ohm resistor. So we'll come in our ProTech Trader box number 2. And we will get a 470 here, 470. Just gonna grab our 470 ohm resistor. That's 47K. Don't want to make that mistake again. 4.7K, 470K, 2.2K. 220 ohms, 330, 47, 470, there it is. Okay, so I made a mistake in a couple videos ago where I put the wrong size LED, or the wrong size resistor in a project, and it didn't work, and the whole video turned out horribly, but I fixed it in the next one. So if you saw the one where it was the dumpster fire, check out the one after that, and you'll be good to go. And we need the helping hands here. Let's grab the helping hands and make a bunch of noise, knocking stuff over. And one of my little clippies came off of there. I am gonna take this magnifier off. And I'm going to raise up my helping hands here. And put this on there like that. Put this on there like that. There we go. So there. I have that all set up, and now I need one large or 2 small pure copper alligator clips. They are in the box. I remember seeing those. Are they over here? Yes, they are. So we have our alligator clips here. So 1 large or 2 small. These are kind of small, so doesn't say we need any wire or anything. So, why do we need 2 soldering irons? Oh, that's weird. Alright. So we have our components laid out over here. Now, the purpose of this experiment is to study the effect of heat. This means we need to know where the heat is going. For this reason, you're not going to use a breadboard. The contacts inside the breadboard would absorb an unknown amount of heat. We don't want to use test leads either, because they will absorb heat. So what we want to do is so we want to wire the LED directly to a 9-volt battery. Okay, hold on a minute. Let's see here. So, okay, low-powered soldering iron, powered 1. Plug them in and wait at least 5 minutes. Make sure it's really hot. Now hold the tip firmly against one of the glowing leads at the same time. Watch. Okay, well, let's see what this is going to do. Let's modify this experiment a little bit. Let's take this LED here, and we will do the resistor on the long lead. We will do the resistor on the long lead here. Let's plug in our soldering iron. This should be the okay, this is the 12-volt supply. It's definitely supposed to be 19, but okay. It's heating up. It's heating up slower than I'd like. So we're going to put some solder on this piece here. Hope I'm going to put some solder on it. Alright, so first thing I'm going to do is I'm going to bring the soldering iron closer, and then I'm going to clean my tip. And I exhale if I'm not using my fume extractor. I'm sure I'm going to get a lot of hate for that, but whatever. So this is the long lead, so I'm going to tin this. I'm going to tin that lead just like that. So let's see if I can bring you in a little closer. Bring you in a little bit closer here. So I'm going to tin that lead. I tin that lead right there. I'll do it again just to show you what I did. So just run the solder across it, just like so. Why did my power supply turn off? Oh, okay, well, I'm switching power supplies now, so okay, I updated the firmware on this, and it likes to glitch out every once in a while. So right now it's only giving me 5 volts, which is extremely irritating. So I don't know why it's doing that. Is this thing? No, the thing's fully charged. This thing has a USB PD, so it should ask for more voltage, but it will work at 5 volts. So, and then we're going to come over here, and we're going to tin this lead of the resistor. We're going to tin this lead of the resistor here. Just like so. And then we're going to take this, and then we're going to flow these two together. So let's make sure, oh, you probably didn't see the tinning of the resistor, but I tinned it. So then we're going to take these, and we're going to flow these together. just like that. So there, they're connected now. So so that is connected. It could be connected better, but so now we have a resistor on the long lead of the LED. Now this is technically 5 watts now, so, or less than 5 watts. So what I'm going to do is I'm going to take my leads from my power supply, and I'm going to plug them into my power supply, and I'm going to change it to 9 volts. 9 volts. Then I'm going to put it on the screen. So power on the screen, yay. And then I'm going to grab my Alligator Clips, that clip on here, and then I'm going to connect this to the 470 side and this to there. And now these wires are pretty beefy, so let's see what happens when I turn on the power supply. The LED lights up. Now it wants us to use the wire. You will need a low powered, plug them in and wait at least 5 minutes to make sure. Now for it wasn't check to see the time with a watch. I'm betting it without burning out the LED. Okay, so we're going to see if we burn out the LED here. So on the resistor side, we're going to see if this LED burns out. May be getting a little bit brighter, I'm not sure. So I'm not getting any issues with that. Let's break out the station, because that will heat up fast. It's set to 375. So we're going to break out the station. It doesn't have a huge tip on it. It's already at 2 something. So, okay, the LED went out. Why did the LED go out? Huh, that was weird, the LED went out. Alright, so let's put this up here. Oh, it's not on camera. We'll do it on this side here. And there, see, the LED went out. Now, because that is a higher watt iron. There, see, now the LED is backlit. Now if I heat it up, it goes out, and then if we wait a bit for it to cool down, it will go back on. So, and it's going to flash for a little bit. And the LED is not warm, but we're heating up that lake. Now let's find out why we had that situation. Movie record has automatically, what? Nobody. Okay, that was weird. Okay, a lot of wire recorder and power, more powerful soldering iron. It goes dark a little quicker. It says it it died, but ours came back on. So So now it wants us to take the alligator clip and clip it to the wire like so, and then let's plug this back in there. So it wants us to take this alligator clip and then hold this soldering iron to there, and it should take longer for the LED to go out. And it's showing how heat can affect your components. Yep, see there, the LED went out. We can hold it on there a little bit longer. And then let's see if we can actually get it to come back on this time. I'm not touching that alligator clip, guys. So it's going to take longer if it does come back on, because that copper is going to hold the heat for a little bit. And basically this shows you that the alligator clip has functioned as a heat sink. So yeah, it's not even leaking any current. It is completely shut down. So this shows you that the copper alligator clip was a heat sink, so it allowed less heat to travel, or allowed heat to travel, but at a slower rate because the copper was dissipating the heat. And see, boom, oh wait, oh, it's back on, yay, because it dissipated that heat. You notice it took a lot longer to come back on because the alligator clip was still on there. So that is the end of this experiment, experiment 13. I'm going to put this over here, turn it off, unplug this thing that's pissing me off, and we will shut down the power supply, take off the power supply, put that to the side, and we will review. So the heat transfer, you know, if you have too much heat in a component, it will overheat and a lot of components will shut down. So that's basically what this is talking about. And if you have like a MOSFET or a transistor, which is a form of diode, it uses bipolar junctions a lot of times, or a field effect junction where you have two dissimilar semiconductors placed together. And that is what a diode is. There's two dissimilar junctions, and current can only travel one way. And if you heat that junction up, you will the unit will fail, and a lot of times they'll fail short. So you'll fail short, and a lot of times they fail open circuit. So MOSFETs in power supplies and switching power supplies and transistors are all forms of use diode technology. I don't want to say they're diodes, but they use diode technology with the different bipolar junctions, and by heating the junction up, you can actually have the component shut down, or you can have the component fail short. I didn't get anything to fail short today, but that is a brief explanation of how heat can affect a diode type device. This can probably be done with transistors and MOSFETs, but with the LED, you get the light off of it and you know it's shut down. So that's going to conclude this video here. This is a short one on the Make Electronics Experiment 13, roasting an LED. The next episode is a wearable pulsing LED light, Experiment 14. Be sure to check back when that video posts. Thank you guys so much. Here's the links to social media and my Patreon account if you so choose.